my basic advice is don't be afraid to fail. Um, I remember that my actual first college exam that I ever took, I actually failed it, and it really did discourage me at first. It kind of almost made me lean away from the pre-med route, I told myself, I'm going to finish this out. I went to tutoring. I went to the teacher's office hours, and I ended up finishing that class with an A. And it's one of the most rewarding grades I've ever gotten in college. And it really helped me just get through these next 3 years to know not to quit even when things don't kind of go how I planned it, or I'm just disappointed. Just to stick with it and don't be afraid to fail, and just use that as motivation to continue and do better. So definitely having time management skills, that's very important for being a college student. For me, I love to use planners. I have a social calendar, then also an academic calendar where I keep track of tests and quizzes or homework assignments. And then my social calendar, I just keep track of events that I need to attend to, organizational things that I need to be a part of. It's really nice to have those two things together and scheduled. And I would also recommend also having extracurriculars, not just being a student, definitely getting out of that student mind frame sometimes and enjoying yourself and enjoying the college life. That's very important. But definitely being responsible and having those time management skills is definitely very important to do. A couple of regrets that I've made is for some classes that I've taken, I really didn't take advantage of the tutoring or the writing center or just other resources that are offered on campus. Sometimes even go into professors' offices. I wish for some of these classes I would have taken advantage of those opportunities. Hey, welcome back everybody. My name is Jelani, and today we will be covering balancing chemical equations. Now, in science, there are a lot of terms, and some terms may seem interchangeable, when in fact they are actually different terms. And two terms that I actually want to cover. First is a chemical formula. So let's write that out. A chemical formula versus a chemical equation. Now, these terms are commonly misconstrued. Well, a chemical formula actually tells scientists the number and type of atoms in a molecule. So now let's start with focusing on our chemical formula. Now, if we just take a simple example, let's say sugar, for instance. Now, if you just take the chemical formula for sugar, that is C12H22O11. Now, what this tells us is that each molecule of sugar contains 12 carbons, 22 hydrogens, and 11 oxygen atoms. Now, let's go back and focus on our second term, a chemical equation. Now, a chemical equation is important to understand, especially since we will be balancing these chemical equations today. Now, a chemical equation is made up of chemical formulas, and it tells the story of their interactions. For example, one such chemical equation that is common is water. So if you start with 2 moles of H2 plus O2 goes into H2O. Now this is a pretty common chemical equation that shows molecules of hydrogen and oxygen combining to make the molecular formula water. Now that we've learned a couple terms, let's go back to our example using water again. Plus O2 goes into 2H2O. Now we're going to dive a little bit deeper and understand some other terms and concepts to know, right? So if we look on the left side of our chemical equation, we see the original compounds before they are reacted. And we'll treat these like our main characters, all right? And they are referred to as the reactants. Now, the formula on the right side is kind of like our end story, and we will refer to this formula as our products. All right? In between our reactants and our products, we have this arrow here. All right? And this arrow designates the yield, saying that if we have 2 moles of H2 plus O2, we will yield 2 molecules of H2O. Now that we have learned about chemical formulas and chemical equations and reactants and products, now let's move on to another very important term to know in chemistry is the law of conservation of mass. Now, this law states that mass is neither created nor destroyed. So, in a chemical equation, the amount of atoms that you start with will be the same number of atoms that you end with. So, you may ask yourself, if we look back at our water example, knowing that the law of conservation of mass states that mass is neither created nor destroyed, you might ask yourself, why do we use an arrow instead of an equal sign, right? The arrow not only indicates the direction that the equation is going to, it also indicates that there is an energy component that might not be equal in the equation. So let's go back to our example with water again. Saying 2H2 plus O2 yields 2H2O. And knowing our law of conservation of mass, that mass is neither created nor destroyed, and knowing that the amount of atoms that we have in our reactants equals the amount of atoms that we'll have in our products, you might ask yourself, why is it that we use an arrow instead of an equal sign? Now, this arrow here designates two things. It tells us, one, the direction that the reaction is occurring, going from left to right typically, from reactants to products. And also it indicates that there is an energy component that may not be exactly equal in this reaction. When reactions occur at equilibrium, instead of designating it with an arrow, we use double arrows. Just like that. And this tells us that the reaction can be driven from left to right or from right to left, from reactants to products or products to reactants. Since we start off and end with the same amount, we're able to balance chemical equations, and this is very important in chemical experiments and for making predictions. Now let's look at another example involving sodium chloride. So we start with 2 moles of Na plus our chloride goes into 2 moles of sodium chloride. All right. Now, the most tricky thing or intimidating thing about balancing equations is actually the numbers. The subscripts, or the small numbers to the right of the element, these indicate the amount of atoms in an element that is contained in a molecule. These subscripts are fact and they are non-adjustable. However, things that we can adjust are the coefficients. Now, the coefficients just tell us how many molecules there are. We adjust these coefficients when we're balancing chemical equations so that we can establish a ratio. Now that we know all there is to know about balancing chemical equations, let's move on to a couple of examples where we will balance chemical equations.
Now, the first example we're going to want to work is a combustion reaction. Now, we're going to do this combustion reaction with methane. And whenever you do a combustion reaction, you always involve the molecular oxygen, O2. And when you combust organic molecules, you always produce two products. One of those being carbon dioxide, and then the other being water. All right. And I left our coefficients blank so that we can actually solve and balance this chemical equation. Now, let's first figure out a list of steps in order to balance a chemical equation. So, I have 3 easy steps for balancing. So, step 1, we're going to make a list of our atoms. Alright? So, we're looking at this reaction. Let's make our list. I'll make a table. And on our left side or our reactant side, we'll notice that we have 1 carbon atom. So we'll say C equals 1. We have 4 hydrogens. And then from our oxygen, we have 2 of those. Alright. Then we go on our right side, our product side. We see that we have 1 carbon. From our carbon dioxide, we have 2 oxygens. And then from our water, we have 2 hydrogens, and then from our oxygen, we have 1. Which gives us a total of 3 oxygens on our product side. Now, typically I always like to start with carbon, and it will be easy to start with our carbon too because there's only 1 molecular formula for 1 carbon for each of these molecular formulas. Alright? So, we're just solving for our carbon. That takes us to step 2. Which is only balance 1 atom at a time. Alright, so we're looking at our carbons. We see that for our methane, we only have 1 carbon that we figured out earlier, and then from our carbon dioxide, we only have 1 carbon. So, we move to our step 3. This is a very important step. Only change the coefficients. So remember earlier in the video when we talked about this, we can't change the subscripts because those are fact, but we can change our number of coefficients. Alright? So, we're just looking at our carbons. We see that we have 1 carbon from our methane on our reactant side and 1 carbon from our carbon dioxide on our product side. So we can go and add our coefficients here. Make that 1 to 1, knowing that our carbons, we have 1 of each. We can check those off. Alright? Now let's move on to our hydrogens. So on the left, we've rewritten our steps out, and we're now going to balance our hydrogens. And once again, we're going to make our list. So that on the reactant side, we have 4 H's, and for product side, we're going to have 2 H's. So, in order for us to balance our hydrogens, we're going to need to multiply our number of hydrogens over here by 2 to equal out to 4. To give us 4 on our product side and 4 on our reactant side. And when we do that, remember our step 3, we can only adjust the coefficients. So we multiply all this by 2. We see that now our number of hydrogens have been balanced, right? But when we do that, we also multiply that 2 by our oxygen. And now instead of having 1 oxygen for our water, we now have 3. So now our number of oxygens are we have our 2 oxygen molecules from our water, along with our 2 from our carbon dioxide, which gives us a total of 4 on our product side. And now on our reactant side, we are still only at 2. So now we're moving on to our oxygens to balance our oxygens out. All right. Knowing that we only have 2 oxygens on our reactant side, and we have a total of 4 on our product side, let's multiply this by 2 to equal out to 4. All right, and when we do that, we need to change our coefficients here. Multiply that by 2, which gives us 4 oxygen molecules on our reactant side, and we total out to 2 from our hydrogen and 2 from our carbon dioxide. We get a total of 4 on our product side. So now once we check all our work, knowing that, looking at our carbons, we have 1 carbon for each side. Our carbons are good. Looking at our hydrogens, we have 4 from methane. We have 4 from our water. And then lastly, look at our oxygens. We have 4 oxygens on the reactant side, and then a total of 4 from our carbon dioxide and our water.